Okay, so we are going to talk about how acids react with alkalis in this video. Okay, before we talk about what an alkali is, let's think about what's a base. Okay, a base is a substance that which will neutralize an acid, and alkalis are soluble bases. And all alkalis make hydroxide ions, OH minus ions in solution, and that will give a pH of greater than 7. Right, now, there aren't many alkalis really, and the only ones we need to know about are lithium hydroxide, sodium hydroxide, and potassium hydroxide. Most other metal hydroxides, so for example copper hydroxide, are insoluble. They won't dissolve in water. They are bases, but they're not alkalis. And I'm sure it hasn't escaped your attention that lithium, sodium, and potassium, they're all group 1 metals. This is the hydroxides are group 1 metals, and all group 1 compounds are all soluble. It's worthwhile remembering that. Okay, so let's have a look at this equation. We've got sodium hydroxide plus hydrochloric acid gives you sodium chloride and water. So quite often the general equation would be alkali plus acid gives you a salt and water, and that's a neutralization reaction. But let's have a bit of a closer look at what's happening there. Right, sorry, so I've drawn these diagrams. Right, now in this here is covalent hydrogen chloride. Okay, when you dissolve that in water, so when you put it in there, all acids make H plus ions. So it dissociates into its ions. It dissociates into the H plus ion, which I've done with the red, and the chloride ion, which is green. Okay, so that happens to the acid when it's put into water. In this beaker, we have got the sodium hydroxide. Now, sodium hydroxide is an ionic substance, so it splits up into those ions, and those ions float about separately, and they are the Na plus ions, sodium ions, and the hydroxide ions, which I've drawn there as a blue oxygen with a red hydrogen attached to it. Okay, and they're negatively charged. Now let's see what happens when we mix them up. Well, your negative hydroxide ion will join up with a water, and we'll join it with an H plus. That will go there, and it will form a neutral water molecule, H2O. So that's what happens there. So we've got 3 water molecules formed in that beaker, H2O, 1 more. So that is our water that we formed. Now, what's happened to the sodium ions? Well, nothing. They're just floating around by themselves, like that, 3 of them. And what's happened to the chloride ions? Well, nothing's happened to those either. So you can see really the sodium positive ions and the chloride ions are actually spectator ions there. You may have come across that idea of spectator ions before. So I'm going to rewrite this as an ionic equation. So sodium hydroxide, it's better really to write it like this, Na plus aqueous, because these ions are nothing to do with each other, and the OH minus ions completely separate in aqueous solution. And again with the acid, you've got separate H plus ions and separate Cl minus ions. When they react, you form sodium chloride. Now those positive sodium ions are floating around by themselves, nothing to do with the chloride ions, which are floating around by themselves. And we've got water there. So you can see we cross out anything that doesn't change. That will be the spectator ions. So we cross that out. We can see that the sodium ions, they don't change. And the chloride ions don't change. So all that's happening is the H plus ions are reacting with the OH minus ions to make water. That's what's happening in that neutralization reaction. Yeah, we've got sodium chloride in this beaker, but the sodium ions and the chloride ions haven't really changed at all. Okay, let's have a look at another acid. Let's have a look at what happens with sulfuric acid next. Okay, so here we've got sulfuric acid. Doing some pictures again, reacting with NaOH. Now that's going to form water, H2O, and the salt formed there is going to be sodium sulfate. The sodium sulfate has got the formula Na2SO4, because don't forget sodium is a 1+ ion, whereas sulfate has got a double negative charge, so you need two sulfates. Yeah, there. Right, so again, let's do all these little pictures. So here we've got covalent sulfuric acid, so that's before you put it into water. When you dissolve it in the water, each molecule of sulfuric acid is going to give two hydrogen ions, the red ones there, and it will give you one sulfate ion, which is the sulfate ion I've done there with in purple with the 2- on it, and you've got two lots of H+ ions. Again, in the next beaker here, we have got our sodium hydroxide. That hasn't, okay, that is split up in Na+ ions and OH- ions. Right, when we mix them together, or what's going to happen, again, the H+ ions are going to join up with the OH- ions to form water. So I've got 4 molecules of water in this time. Okay, and we have got, we've also got, what's happened to the sodium ions? Well, nothing. They've just stayed the same. So I've got 4 of them. What's happened to the sulfate ions? Nothing's happened to those. So the sulfate ions, they're just floating around. Nothing, they haven't changed. They're spectator ions as well. So let's, well, first of all, we need to balance that equation, don't we? So I need to put a 2 in front of the NaOH, and I need to put a 2 there. And if we rewrite that as an ionic equation, I'll just write it above. There's not enough space. So it's going to be 2H+ from the sulfuric acid, sulfate ion from the sulfuric acid, but 2 Na+ ions from the sodium hydroxide. They're floating around, nothing to do with the 2 OH- ions, which are also in the beaker. And then they react, we're going to get our 2 H2Os. That's with the H+ reacting with the OH-, and we are going to have our sulfate ion unchanged and our 2 sodium ions unchanged. Okay, crossing out anything which appears on both sides of the equation, we can see sulfate, that doesn't change, and the sodium ions don't change, they're spectator ions. So again, all that's happening is H+ is reacting with OH- to make water. And here, well, what we were left with was we've got water, but we've got a solution there of sodium ions and sulfate ions in solution, so it's a solution of sodium sulfate. Right, last one, the last acid, do the same again with nitric acid, see what happens there. Okay, so nitric acid, when it reacts, you're going to get water and you're going to get salt, and the salt this time is going to be sodium nitrate, and that's the formula of sodium nitrate because sodium is a 1+ ion and nitrate is a 1- ion, so that's the formula of sodium nitrate. Right, this is our nitric acid here, covalent nitric acid. Before you dissolve it in water, when you put it into the water, it's going to split up, dissociate into positive hydrogen ions shown in red and negative nitrate ions shown in yellow there. Again here I've got my beaker of sodium hydroxide, so I've got Na+ ions floating around. They're the silver ones, nothing to do with the negative OH- ions also floating around. When they react, what's going to happen? Well, again, we're going to form water, so I'm going to form 3 molecules of water there. and the sodium ions remain unchanged, so they're just floating around still, 3 of them. And the nitrate ions, they remain unchanged as well, 3 negatively charged nitrate ions. So you can see again, all we've done is we've reacted with water, and we've got some, we reacted to form water, and we've got some spectator ions. Right, so if we write that as an ionic equation, so split the nitric acid up into the ions, so it exists as H plus ions in solution, and nitrate ions. The sodium hydroxide is that, and H minus ions, and that's going to react to form H2O. The sodium ions don't change, the nitrate ions don't change. So if we look for the spectator ions there, what doesn't change on both sides, we get rid of the nitrate, and the sodium, So once again, we've got H plus ions reacting with hydroxide ions to form H2O. So ionic equations show you more, give you a better idea of what's going on really, rather than the full equation, which you don't fully realize, right? In the full equation, that the sodium ions and the nitrate ions don't actually undergo any chemical change in that reaction.